Hello everyone, thank you for coming today. How are you? Are you feeling good? Yeah? All right, perfect. So happy to have you here today. First of all, let us praise and thank God because of His mercy and blessing. We all can gather here together today. Um, are you ready for this session? Are you ready, guys? When I ask, are you ready? You need to answer ready, ready, ready 3 times. Okay? Yes. Let's do it once again. Are you ready for this session today? Ready, ready, ready. Cool. Awesome. All right, guys. Today we are gonna unlock a powerful tool in calculus, which is a definite integral. Okay, before we jump into any formula, I'm gonna explain to you a little bit about our objective today. The first one is we are gonna understand the core concept of a definite integral as a limit of sums, and then the second one we need to solve the basic definite integral problems to find the exact area under the curve. Okay, sounds amazing. Yeah, all right. We're gonna learn this in today's session. So, all right. Before we look to any formulas, I'm gonna ask you a simple question. How do we measure the surface of an area around us? For example, how do we measure the area of football pitch? Can you? Yeah? All right. Yeah, it's easy, right? Because it's only a rectangle, you can apply the formula. The area is equals to length multiplied by width. Very easy, right? Now, the second one. How gonna we measure the area of like our front facade of our house? Can you? Yeah. All right. It's also easy, right? Because we can just break down them. We have two shape here. We have the triangle and also the rectangle. Rectangle. We can calculate them each, and then after that we can add them up. Easy, right? Now look at this modern building with a beautiful sweeping curved roof. How do we calculate the exact area underneath the curve? Standard geometry formula fail us here. So what's our solution? Yeah, have a look. Um, let's formalize the problem. Imagine that we have this kind of problem. Basically, we have this curve. This is fx equal to x square. Now, it's hard, difficult for us to separate them into several shape. So we are going to try to approach them by attempting to partition them. For example, here we have 4 partition. First one, second one, third one, fourth one. But as you can see, we have the gaps here. These are very large gaps here. Also here, also here. That's why we cannot find the exact number of this area, the surface of this area. It's hard for us to find the exact number. That's why we have the solution here. Now, as you can see, we have 3 pictures here. The first one, we separate them into 4 partitions, and then the second one, 8 partitions, and the last one is 30 partition. As you can see, when the number of partition increase, the gaps is decreased significantly, right? As you can see, we have large number of gaps. It's getting smaller and very small over here. So based on that, we can conclude that as the number of partitions approach infinity, the width of each rectangle approaches 0, and the calculation error vanish entirely. You can see what I mean, right? So the integral can help us to answer this kind of problem in our real world. Now, all right, to write this mathematically, basically we have this kind of curve function, and then we have the lower bound, we have the upper bound, and we can write the integral symbol as this, and then we put the lower bound here and upper bound, and then we put the function, and then the last one be differential. All right, that's the notation that we're gonna use. Okay, now the rule, basically the very basic formula that we're going to use in order to answer this kind of uh, problem is we are going to use the integration power rule. So basically, as you can see, we have integral cx power of n dx is equal to, we just move the c over here, and then we divided it by n plus 1. And then the variable, before we have x power by n, and then we just add 1 to the n. So you're going to have the x power by n plus 1. This is right. Yeah, it's, I know. Can you imagine that? All right. Now, let's solve our problem. So basically over here, we have like a curve over here, and then we are gonna try to calculate the surface of this area. So basically we have this function, which is fx x squared, and then the lower bound is 0 and upper bound is 1. So to answer this question, we have 3 steps. The first one is apply the engine that we already learned before, right? The first one, apply the engine. So basically, we have integral c x is equal to c divided by n plus 1, and then x the power of n plus 1. So we can substitute the function using our real function. So basically, we're going to have integration of uh, x squared dx. What's going to we have? C is 1. So we have 1 divided by 2 plus 1. So we're going to have 3 and x powered by 3, or x cubed. All right, this is what we have. And the second step is set the boundaries. We have the boundaries. Remember that? All right. Our boundaries is 0 to 1. And then the last part is we evaluate it. The first one, we put the upper bound first. So basically, we're going to have our upper bound, 1, and then we substitute it by our bound. So we have 0 cubed. What's the answer? It's 1, so we have 1/3, and substituted by 0 because we have 0 over here. So our final answer is 1/3. So we can conclude that the measure of area over here is 1/3 unit. Depend on what unit that we're gonna use. It's pretty simple, right? All right. Next one. I have provided the 2 paths on the board. So basically, you can answer the first question first, the core target, and then for the one who need more challenge, you can try the extension target. So let's pause this video and let's try to answer this kind of question, and I'll be back in the moment. All right, guys, welcome back. Have you answered all the questions? Okay, yeah, you have answered this. How? It's easy, right? Yeah, you can do it. Okay, let's verify your hard work together. Okay, for question, the core target. As usual, we have 3 steps. The first one is apply the engine. So basically, we're gonna have 3x powered by 2, 3x squared. So we're gonna have 3 divided by 2 plus 1. So we have 3 here, x cubed. So we are gonna have x cubed. Okay, the second one, set up the boundaries. So we have the x cubed, and then the boundaries 1, 2, 3. And now the last step, we evaluate this. Okay, we set the upper bound first. So this is 3 power by 3 cubed and minus 1 cubed. So we have 27 substituted by 1. So the answer is 26. Easy? All right. Now, for the extension target, because of the time, I'm gonna send to you the solution and you're gonna verify by yourself. Give applause for your hard work. It's very good to have answered this kind of question. All right. Okay, guys, to wrap up our lesson today, I always remember that definite integration is simply a brilliant way to adding up infinite ultra-thin rectangles to calculate the absolute exact area. So you have the exact area, not only the approach to find the nearest area, nearest answer, but this is the exact area. Okay, before you finish today, take a look at the self-reflection scale today. So basically, we have 1 to 5. You can use it to evaluate yourself. If you think that your score is 3 or below, feel free to reach me out. I'm going to explain to you, or you can rewind this video to try to understand how we answer this kind of problem. Okay, thank you for your amazing focus today. Give applause for all of us. It's amazing. Okay, guys, thank you. See you in the next session with our new material. Bye bye.